As discussed in the earlier video, today I will explain you the difference between torque and moment. Now we are already familiar with this case of pipe and a wrench. Now I am applying a force. This is the axis which I have taken, x-axis, y-axis and z-axis. Now let me explain in brief what is this arrangement. This is a pipe. Consider a three-dimension pipe like this pen, and this is a wrench which is used to give motion to the pipe. Now first of all, let us give a force, apply a force which is parallel to x-axis. That is this force, we can say that f of x. Now this force will try to move this body or pipe in clockwise direction, in anti-clockwise direction. Like this is the pen. If I will apply the force over here, then it will try to rotate this body in this direction. Now, so as per right hand thumb rule, we can find the direction of the moment. So the direction of the moment will be in upward direction, and the sense of rotation of this pipe would be like this. So now I will okay, let it be. This is the case for when we apply the force in x direction. Now let us take this another case in which we will apply the force which is parallel to z axis. Now this is the force which is parallel to the z axis. We will take it as fz. Now this force will try to rotate this body in this. You can visualize this. If this is the body now, and I will apply the force. I apply the force over here. Then this force will try to rotate this body in this direction. That is, this body will try to rotate with respect to x-axis. So I can say that by right hand thumb rule, the moment vector would be coming outside in x-axis, coming outside x-axis, that is moment, and this would be the sense for force f of z. Now let us consider this fx force. Now consider a cross section of this pipe. If this is the pipe, then its cross section would be this. I can show you this in exaggerated form. This is the cross section. Now this moment vector is perpendicular to the cross section, so this will try to produce torque in the body. Now consider this section. Here also the cross section would remain the same. I will also show this in exaggerated form. So this is the cross section area. Now see this. Here the moment vector, this moment vector is not perpendicular to the cross section, but this moment vector is in direction of the cross section. That is, the angle between the moment vector and the cross section is 0. So this moment vector will try to produce bending moment. So if moment vector is perpendicular to cross section, then it will produce torque, and if moment vector is parallel to cross section, then it will produce moment. This is the difference, basic difference between torque and moment. We will further analyze the more difference between torque, moment, shear stress and the further stresses.